Welcome back to the friendly confines of Beat 326. We want to add one more name to the scientists who were key figures of the scientific revolution. In the PowerPoint, you learned about Copernicus and Galileo, and today we're going to use a mini lecture to learn about Sir Isaac Newton. Now, in Westminster Abbey, one of the great thrills for me is to stand in front of the sarcophagus, the tomb in which Sir Isaac Newton is buried. And alongside him in the floor of Westminster Abbey, right next to him, is the gravesite of Charles Darwin. And so today I'm going to try to explain in just a few minutes why it's such a thrill to go there and pay your respects, so to speak, to Sir Isaac Newton. So we already know, since I mentioned Westminster Abbey, that Sir Isaac Newton was English. And Sir Isaac Newton published in the 17th century, and his major book came out in the 1680s. And once his book comes out in 1687, then that's pretty much the turning point. The heliocentric worldview that we've been learning about is more and more accepted. It starts to get into the mainstream. So, for example, when the Puritans come to New England and they establish Harvard, they're teaching Newtonian physics beginning in the 17th century, the late 17th century and early 18th century. Now, here are some of the reasons why Sir Isaac Newton is considered one of the greatest scientists of all time. Number one, he provides a synthesis. What he does is combine elements from Copernicus, Galileo, and other people like Kepler, who had gone on before him. So he takes all their ideas and he shifts through them. And that book that he publishes in 1687 provides a synthesis and pretty much establishes the new worldview as the dominant way to look at things. Number two, he will argue that the universe operates on the basis of natural laws. So there's a system in place that the universe follows, so to speak, natural laws. Now, we probably all heard the story. Isaac Newton is sitting under a tree, and an apple falls from the tree and lands on him. And as a scientist, he's compelled to try to offer an explanation. There must be a reason why this happened. And so that's one of the natural laws that we associate with Newton, gravity. Now, the story is probably folklore, but it does illustrate this point that Newton was determined to discover what the natural laws were, and that's how he develops the system that becomes known as Newtonian physics. Now, here's a third major point. Let me get myself a bit of space here on the board. Okay, here's the connection to human beings. We have the ability, Newton says, to discern the natural laws if we use, now I'm going to use the word reason here, answer this in many different ways. You could say we have the ability to discern the natural laws if we use experimentation, if we use the scientific method. But the thinkers who are going to come after Newton are going to argue that reason is really the most important and the newest authority. They're going to argue that only those things which can be established by reason can be trusted or believed in. Now, Newton doesn't go quite that far. He sees reason as a new source of authority, but it can also just complement older sources of authority like tradition and even religious authority. So Newton believed that the universe operated on the basis of natural laws, but he also believed that there was a God who had the ability, who created the whole system, to, for a time, suspend those natural laws so that you could have things like the miracles that you find in the creeds that the Christian church professes, for example. Now, the more radical thinkers will come after him in the Enlightenment, and they will often argue, the most radical of them, that reason is the only authority, and you can't really trust anything else other than reason. Now, here's then what separates these scientists, Copernicus, Galileo, and Newton, apart from most, not all, but most of the thinkers that came before them. These guys were not satisfied to just accept what they were told. They didn't believe something simply because it was in a book or a textbook. They didn't believe something just because a professor said it. They asked questions. They wanted to know why something should be believed. There had to be good reasons for it. It had to be based on actual facts and reason. And so that's why these three were so key in the scientific revolution. And that's why, for me, it's such a thrill to go to Westminster Abbey and, in a sense, pay my respects to Sir Isaac Newton. And that's our mini lecture on Sir Isaac Newton.